I have put this article up to condemn it, and it was published in no less than the Scientific American in October last year. And this guy says, now, extractable oil in any oil field is only about 35%, but he says we can get the other 65% no problem because technology is wonderful. And it's true, with horizontal drilling or proximate reservoir drilling, you can actually access pockets, little pockets here and there, which were previously inaccessible. But you won't get anything more than the 35 or 40% of the oil, and there's a real good reason for this. And it's called EROEI, energy return over energy invested. What does this mean? In a pristine oil well, there's positive pressure, it shoots out of the ground, your energy return over energy invested of drilling is like 100 to 1. As the pressure declines, then you cannot passively obtain oil, you have to actively extract it. So you have to use energy to extract that oil. You start pumping in carbon dioxide or saline. Now you reach a point where the returns are 99% saline and 1% oil. When you reach the point that the energy you put in is more than the energy you get out from that oil, it doesn't make any sense whatsoever to persist trying to extract the remaining 60% of the oil in that well. It's just crazy. But there's some people who feel that they can still do it if they get good government subsidies. So long as they pay to do it, they'll do crazy things. Who is this guy, Leonardo Margeri? He didn't even mention EROEI, which is one of the most important concepts when considering petroleum issues. This guy is a vice president of an Italian oil company and an economist. Now, I have great respect for Scientific American. The popular scientific press are very important for publicizing scientific issues based on the best peer-reviewed scientific research and written by scientists. There is no place, in my opinion, for an economic delusionist to have a publication in that magazine. Maybe he paid them. Anyway, here's my example I'll show you of a cornucopian delusionist. And this is what happens when you use modern technology to extract oil as fast as possible. This British North Sea oil peaked in 1999, fell off a cliff. Here's another reason why the oil will be even less available to us than we would like to think. It is because in most of the oil exporting countries, they have young populations. More than 60% of the Iranian population are under the age of 30. Indonesia has a young population. Vietnam, we get much of our oil from, has a young population. In Saudi Arabia, the average number of children is 6 per family. So with those expanding populations, those oil exporting countries will want to use more and more oil in the future for themselves, and there will be less available for export. This is called the export land model of petroleum availability. And by 2040, 30 years from now, there will be nothing for us. So how can we get more oil? That's conventional oil I'm talking about, which is liquid, easy to pipe out of the ground, found in shallow deposits and has a high EROEI. What about non-conventional oil? Heavy crude tar, you can't pump out the ground, you got to scoop it out. It takes more energy to access. Super deep water, floating oil rigs. Here's an example of super deep water. In 2006, they were announcing the Jack 2 oil rig in Gulf of Mexico. 10 million barrels of oil, maybe. Still wouldn't be able to last the world more than a few months. There's something 3 kilometers of water and 5 kilometers of rock. 8 to 9 kilometers of piping. Imagine that. In a hurricane-prone area. Cost them about $3 billion to establish that rig and almost $1 million a day to run. Non-conventional oil. Polar oil, speculative. Russians very interested in oil under the Arctic Sea. Tar sands. Now I have to mention this because it seems like one of the most optimistic possibilities. They say there's like 2 trillion barrels of oil in the oil sands of Athabasca. But the thing is, you have to use massive excavators which are run on liquid hydrocarbons to scoop them up. You have to bring them over to a central processing area, and you have to use natural gas to boil off the tar from the tar sands, and you've got to use loads of fresh water as well. These tar sands are very dispersed, not concentrated, very hard to get your hands on. So it reminds me of the Blackadder joke. Blackadder's trying to get some money from some rich relatives, and he says to Baldric, Baldric, their wallet's as capacious as an elephant's scrotum and just as difficult to get your hands on. So that's the tar sands in Canada. Al Gore has called it the subprime mortgage scheme of energy. Colin Campbell said, when he heard of the tar sands, he said, "Gentlemen, we have discovered a way to turn gold into lead." It does have a ERO-EI of more than 1. It's about ERO-EI about 3. So that's what kind of makes it economically viable. But the carbon emissions that are created are 3 times more, and it's going to deplete the natural gas of Canada. And more important than that, why is the tar sand scheme folly? It is this. The University of Uppsala in Sweden calculated, they did a study on asbestos and tar sands, and they calculated even if they used all of natural gas in Canada to process the tar sands at the fastest rate possible, the greatest rate they could create it would be 5 million barrels of oil per day. 5 million barrels hardly makes a dent in the 85 million barrels we use. Synthetic oil, coal, natural gas also through the Fischer-Tropsch process would create massive quantities of CO2. Biofuels and grain is ridiculous, unethical, not viable. So here's an example of extracting non-conventional oil. It's a super deep water scheme, it's Deepwater Horizon. And a few years ago, ethanol from corn in Nebraska is another crazy idea. The ERO-EI is less than 1. The only reason they do it is because of the corn lobby in the States, which gets subsidies from their government. And when they diverted corn as feedstock production of ethanol, there was a shortage of corn in America, which is a staple for the diet of Latin Americans, and they had what's called the tortilla riots in Latin America in 2006. People were hungry. So this is the future we face, and I think if it's a poor person versus an SUV, that poor person is going to get crushed. The greatest force in the universe is compound interest. That's what Einstein said. Man's greatest failure is his inability to understand the exponential function. That's what Albert Bartlett, professor of physics, said. And this is the trajectory of our population enabled by fossil fuels. So I want to finally show you this because I'm running out of time. I've got a lot more slides, but I'm running out of time. This will be pretty much one of my last few slides. Now this is a well-known bell curve. I've shown you a few bell curves. One was oil discovery, another one was oil production. Another bell curve follows oil production very closely, oil consumption. And here's another bell curve, which is a result of that oil consumption. It is a well-known curve to all biologists. If we were yeast, there would be no argument. It is the boom and bust curve of a plague species. No way we're going to reach 9 billion, I would say. If we were if you imagine a population of rats and you give them a windfall of grain, and they consume all that grain like there's no tomorrow, then suddenly one fine day, no more grain left. What do you get? A population crash, you get a die-off. And the remaining rats survive by cannibalism. So this is my proposition to you. If we do not rise to the occasion, we pride ourselves in our ability to think and plan, but if we do not think and plan for the future, we will prove to future historians that we are no better than cannibalistic rats. Donald Rumsfeld, one of them, Richard Cheney, American psychopath. That's an accurate term, and I've justified it by this, which is something that Kurt Vonnegut said, but I won't go through that. We are addicted to fossil fuels, no doubt whatsoever. I won't go through that either. People is just one manifestation of a whole host of ecological, environmental, and economic crises we will be facing very soon. There's peak coal. There's peak uranium. I call this slide, I used to call it the 4 horsemen of the apocalypse, but I actually call it now the 3 horsemen of the apocalypse and the 1 big fat elephant of the apocalypse. Crazy idea, burning methane hydrates. We burn methane hydrates in the ocean floor, we will guarantee to render ourselves extinct, no doubt whatsoever. Just an example of how medical management versus planetary management can be compared. No time for that. So, what are my conclusions? Fact, you are not being alarmist if you're telling the truth. Fact, if a situation is dire, it is essential to tell the truth so that measures can be taken to prevent death. Fact, if a situation is dire, it is the delusional, hubristic optimists who are irresponsible and dangerous. Thank you for your attention.